Hello, science students. This is Miss Potter, and I'm going to present to you part 1 of the study of Earth's history. So to begin with, make sure you're taking notes on 18 IP. At the very top, we have the key concept. Slow geologic processes and major catastrophic events have shaped Earth's surface in the past and continue to shape Earth today. So it's kind of a mouthful, but basically just think about it as there are slow processes and there are very sudden or quick processes. And both of these things are shaping and changing the Earth the same way that it did when it first formed and how it is today. James Hutton is a scientist, and this is question 1 on your paper. He is a scientist that stated that things that change Earth's surface today are the same as what changed it in the past. So this goes along with our key concept. So he's the one who actually noticed and saw that things are happening basically the same, and there's lots of processes that are occurring, and most of these are actually very slow geologic changes. So he observed that the broken down particles were breaking off the hill. That's number 1. He watched them then go down the stream. The stream carries it. It's a moving body of water. And along the way, some of them were getting deposited on the shoreline, forming new layers. So this process just repeated itself. New particles fell down, new particles got deposited. So this is the process of erosion and what we call deposition, depositing of new sediment, which are little tiny rocks. So uniformitarianism, okay, your last question here, the idea that the same geologic processes that shape Earth today have been at work throughout Earth's history. So example, processes like erosion and deposition do not change over time. These processes are the same. Doesn't matter if we're talking 100 years from now or 100 years before now. The erosion and deposition still occurred. So erosion would be the sun, the wind, the rain that erodes the little particles of rock away. Deposition, just look at the root word there, deposit, and all of these particles of sand or rock are getting deposited in new locations. So these processes happen the same, and they do not change over time. So down here I have that this is a gradual geologic process. Okay, so think of gradual as being very slow. If we looked back at this rock formation 100 or 1,000 years from now, it's going to look pretty much the same. There will be changes, but to our normal observing eye, we are not going to see that there are any changes. So example, this is the very last part of your paper of uniformitarianism, Processes of erosion and deposition do not change over time. Again, another formation here. We're not going to notice. Maybe parts of this is going to fall off through erosion, but then new layers will do. So you can see that these layers have been piling up, and each layer marks a new different time frame. Really fast, another couple examples right here. I'm not sure if you know what this is. Maybe some of you have visited over summer vacation or so, but that is the Grand Canyon. So excellent example of uniformitarianism. Very, very slow changes. Over here we have Mount Everest. So any mountain ranges would also be uniformitarianism. So I do want you to think about what we just talked about. We talked about slow geologic changes, which is uniformitarianism. You're now going to go over to 18 OP. On the outside of that foldable, you're going to draw a picture of some kind of formation that's going through this slow geologic change. So we're staring at 2 pictures right now. You could use one or think of your own. On the inside of that foldable, there are 2 things you need to do. Write a definition in your own words, and then give 2 examples of what that word means. So example, Grand Canyon could be one of your examples. So you're going to be working on that until it is time to rotate to your next part. Thank you so much.